Alright, welcome back. This is the discussion video for section 10.1, Systems of Linear Equations. There's a few questions here, so let's dive into them. We're looking at number 7 first. So, it says use any method to find all the solutions of the system of equations. So, in our videos, we talked about a couple, the substitution method and the elimination method. Those are the two main ones. So we'll probably use the elimination method as much as we can because that's the one that I like. The substitution method also is good. It works for number 7 quite well as well. But let's just take a look at it and see what we've got. Our system is x plus 5y equals 13, and 5x minus y equals also 13. So this is our system, and what I would do is try to match up the coefficients on my y's because it's easy to just multiply the bottom equation by 5, left and right hand side, to get a minus 5y. So that I could combine it with the top equation to eliminate those. So I will. That's what I'll do, is I'll just multiply the left by 5 and the right by 5 on that bottom equation. This gives me an equivalent system of the top one didn't change, x plus 5y equals 13. The bottom now is 25x minus 5y is equal to 65. Now if I combine these two, add the left together, add the right together in the elimination fashion, that gives me 26x. The y's are gone. And this right here may be the one reason that substitution may have been better, because then you don't have to divide by 26 in the next step. But too late, we're here, so here we go. Equals 78 on the right hand side. And if I divide this by 3, or sorry, if I divide it by 26, I get 3. And I'm halfway home, right? X equals 3. To figure out y, plug it into one of these guys. Doesn't matter which one. I'm going to go into the second equation before I gunked it up by multiplying by 5. Because I have 5x, which I know is 3, so I have 15 minus y equals 13. Subtract 15 from both sides. That gives me negative y is equal to negative 2, and divide or multiply by negative 1 gives you y equals a positive 2. So that's my solution, 3, 2. It asks for an ordered pair, always in parentheses, 3, 2, done. Okay, good. Let's also look then at 9. Nine says the same thing, use any method to find the solutions, and we're given the system negative 2x plus y equals 1, and 4x minus 2y equals negative 2. And after you've done a few of these, you should be able to recognize that we're in one of those special cases, because the top one, if I were to multiply it by negative 2, I would get the bottom one, right? So these aren't going to be the same line. But I'm going to go through the motions here. If you can't recognize that, and sometimes it's not easy to, I would multiply the top one by 2, looking maybe at my y's to get a 2y so that I can combine with negative 2y to eliminate. That of course gives me the equivalent system of timesing the top by 2 gives me negative 4x plus 2y equals 2, and then the bottom I have 4x minus 2y equals negative 2. And if I combine these, I get 0 and a 0 and a 0. But this is a true statement. Right? If I boil down to a true statement, these are the same line. There's an infinite number of possibilities. But I have to express my answers because it's not just anything, right? It's anything on this line. This is a line that's just those values. So I have to express my values as x and y, some sort of x comma y, which I can express as pick an x and then there's some y that is a function of x. Or I can express it as pick a y and the x value is a function of y. It doesn't really matter. It's going to be one of these two in the end is the answer. I just need to figure out which one. So let's assume that we pick an x. If I pick an x, then let's use this first one. Then my answer is going to be some x, comma, and then whatever this function is, I don't know, but I can figure it out. Let's take this first one, negative 2x plus y equals 1, and solve it for y and see what y turns into. And that's easy enough to just add 2x. So you get y equals 2x plus 1 is how I'll write it. So that would be the function here, is whatever x is, you just take 2x plus 1, and that's the y value that couples up with it. This is a perfectly valid answer. Okay? It's not the only answer. Let's say we pick a y and figure out what x is. In that case, we're going to have some y value, and then whatever x is has to be the appropriate x value to match up with that y. But how do I figure out what that y is, or sorry, what that x is? Again, I just have to solve one of these for x and see what it is. So this minus 2x plus y equals 1. I want to solve for x, so I'm going to subtract y to the other side. That gives me minus 2x equals 1 minus y. And then if I divide each side by negative 2, I've isolated this. This is getting a little messy, but isolated the x on the left. On the right, I have 1 minus y over negative 2. Okay. I'm going to clean up this section just a little bit so that I can start over here because I'm not quite done, right? What I want to do is get this negative out of the denominator. But I can multiply top and bottom by negative 1 to do that. That gives me x equals, the negative gets distributed through the top, so it's negative 1 and plus y, and then over 2. A lot of people hate to see that negative in the front, so they'll just switch the top. And if you're on a test where you're writing this stuff down, it doesn't matter. If you threw this in here, good, you're right. But we're on a multiple choice question here, so we just have to find the one that works. And so this one right here is the value that they have. And so you have answers of y minus 1 over 2, comma y, noting that you would pick the y. If they had an x, comma 2x plus 1, that's equally valid. And I don't see that down there. In fact, I don't see, there is one x value, but it's wrong. So this is your ordered pairs as a function of y. Okay. Hopefully that was helpful. I'll see you guys for the next one.